as well.
Okay, just started here. Can you see my screen now?
Yes.
Okay, cool. Okay. So let's start. Okay, so first of all, thank you to Nico to call me, to invite me to speak here in the Memory Virtual Chapter. I said before, we will talk today about the monitoring challenge for Memory OLTP. So it's a kind of new technology. We still have a lot to explore here. And yeah, we have new implementations coming. So not too much experience, but I try to find something to help us in order to keep the system up and running. Okay, so about me, my name is Murilo Miranda. I am lead database consultant at the Pythian Group. It's a Canadian company based in Ottawa. You have here my contacts, my LinkedIn and Twitter if you want to talk to me. And agenda for today, basically why monitor actually. Um, Most of you know why to monitor, but I will review this. Also, we will do a quick revision on in-memory OLTP for who never saw this before or who never worked with the memory before. Then we will dive to the reason of this presentation, what to monitor. Of course, I have more than those 3 points here. But we don't have time to talk about more than this, and I hope 1 hour is enough for those 3. And in the end, how to monitor, but the focus here will be in explain what to monitor and the reasons why I choose this. Okay, in the end I will show some solutions to monitor those 3 points, the buckets, checkpoint files, and available memory. But just to show, and I will make this available as well as the presentation to Nico, so you can download this, tomorrow maybe. Okay, so let's start. Why to monitor? So this lady is the final user. Why a lady? Because 99% of the people in IT are men, so a lady is always a motivation for us to think that the lady is the final user. So the final user is this lady, and your goal is make her happy. Make her happy because her feelings matter to you. So the final user is the thermometer of your system. The final user will react. So you can see, of course, I didn't have a blue screen here. This was just to test the reaction. Of course, I cannot see your reaction here because you're not in front of me. But the reaction of the end user show us if our system is going well or not. And we hope that the final user is always happy with our services. And monitoring makes this job easier, so you can be proactive and not reactive. Okay, of course, by monitoring the system, you have few levels of alarms, and the lower one will just show you that something may happen, some problem, some incident may happen in the future, and you'll be reactive, you will react to this alarm. But this is, I can call this a proactive reaction. So you can, at this stage, identify the problem, correct the problem, and don't need to be reactive when the problem arrives with all its power. Okay, so go ahead. We can monitor SQL Server using a few different approaches. The most common is using third-party tools, which can be free. We have free tools and paid tools, very good tools out there. But we can make our custom solutions using few kinds of different stuff here. For example, PowerShell, using the SQL Server alert system. Of course, this will depend of the motivation of the monitoring, the kind of monitoring. But in this session, I'm going to focus more in what to monitor and not on how to monitor. But in the end, as I said before, I will show you some solutions to monitor the 3 points that I will show here. And for instance, I'm going to use the customized scripts, the MVs, and PowerShell. Okay. So A quick revision of Memory OLTP for who never heard about this or who never had contact with this. Will be very overview, okay? Memory OLTP was introduced in SQL Server 2014, little less than 1 year ago, officially. As Nico said, this is also known as Hackathon, was the name of the project. And Hackathon means 100 in Greek, because the objective of Microsoft was improve the performance by 100 times. Nowadays, we can reach something around 30 times faster, which is very good, in my opinion. Just think if you have a query with problems, okay, performance problems, and you hit this, if you improve the performance by the double, like reduce the time, the execution time 2 times, it will be a very good improvement. And Hackathon at this moment can be up to 30 times faster than the traditional databases. How this is done? This is done by putting your data in memory, so you can reach the best performance. You don't need to access the disk. Okay, it's not that straight way. Okay, but you can avoid a lot the use of the disk. So the few new components were introduced within Memory OLTP. Maybe the two main ones are the Memory Optimized Engine and the compiler. So everything in the Memory Optimized world is compiled. In the traditional database nowadays, you need to parse the code, normalize, create an execution plan. So all those steps are made by the compiler. You can skip this. And the Memory Optimized Engine is a kind of, it's a version of the storage and the relational engine that you have in the traditional databases. Okay, so you have also two new different kind of indexes, the hash and the range indexes, and also you have checkpoint files. I will talk more about both indexes and checkpoint files in the third part of this. More about checkpoint files and only about hash index and not range. Okay. So limitations, as said before, Memory OLTP was released like 1 year ago, just 1 year ago, and was the first version. So we have a lot of things to improve. So this makes, the utilization of Memory OLTP is not very much adopted because you need to have a very specific scenario to make this worse. To be used. So I will not pass each item, all the 8 items here, but I will talk about the most important. For example, not the limit of the table, the limit, of course, of 250 is something to consider, but for example, you cannot change the tables after the creation. So when you create a table, you need to create also the indexes, okay? And you need to think a lot before this, because after the creation of the table and the index, you cannot modify anything. Okay, this is a limitation for this first version. Also, high availability and disaster recovery solutions. Database mirroring is not supported, but always on is supported. Replication works, but we have limitations. You have few small things here. Also the number of supported data types is limited. Yeah, as I said before, you need to have a very specific requirement to go and adopt this at this moment. But if you have some scenario that fits with the Memory OLTP, with this reality, you get a lot of value from the solution. Cool. So the revision is done, so let's check what to monitor now and checking the weaknesses. Okay, so to make this presentation, I started to look for some weaknesses of Memory OLTP and found some, but I selected only 3 because of the time, as I said. And the weaknesses are the things to monitor. For example, in that picture in the right side, you can see someone built a fancy security barrier there, but you have a button, and anyone can put the arms there and click not click and press the button and open the door, which is a security fail. This is a weakness of this security of this place. So in Memory OLTP, I identified the following weaknesses. This doesn't mean that this is something that is not working, okay? It's just something that you need to take care and have the heads up in order to avoid problems, okay? So first one is the index bucket. I will explain what is this, okay? Checkpoint files and available memory in the server. If you look for available memory, it's something that we already do. We already monitor the memory in the server for traditional databases. Here is not different, but I will show you why this is important here. Okay, so starting with the bucket count now. Memory OLTP introduced two new types of indexes, as I said in the revision, the range indexes and hash indexes. Every memory optimized table needs to have at least one index and up to 8 indexes per table. Why this must here? Because the way the rows are connected in the memory table is through the index. The index makes the chain to connect all the rows inside of a table. So indexes are part of the table creation. So you need to think very well what to do and what you're going to need. Okay, what are the requirements before create the table, and you need to know the data that will be there, because you need to make decisions before receiving the data, before test this in production. So it's not an easy task. I'm going to talk here about the hash index, not about the range index, because this problem with the bucket count is applicable only to hash indexes. So what is a hash index? A hash index is a collection of buckets organized in an array. You can see in the picture here, this is kind of array. You have a hash function, okay? And when you define the index, you are defining an index key. And this index key will be parsed to this function, and this function will create a hash which will map this index key to a bucket. Okay, so this bucket count should be specified when we are creating the index. So we need to choose the right value, because this will directly influence in the performance. And what are the possible problems here? First one, have a too low number of buckets. When you have like a very high number of distinct index keys and a low number of buckets, you will have hash collisions. And this is bad for performance. I will explain this better. Okay. And the second problem is a too high amount of buckets, because of performance reasons, this is not good to have, and also you are going to waste memory. Each bucket uses 8 bytes. It's not too much, but it's memory. Okay. So to explain this better, I'm going to tell a story about the fisherman. Okay, this guy in the picture here is Bob. Bob used to be a DBA, and he heard rumors about DBAs losing jobs in the future because of the cloud and because of big data, all this stuff, and he decided to become a fisherman. So Bob is a very ambitious fisherman, and he bought a lot of buckets, you can see in the picture, to put each kind of fish that he fishes inside of the bucket. So he can be organized. So he labeled all the buckets with the name of the fish. And this way, when someone goes there to buy a fish, he just looks to the label and grab the fish from the right bucket. Make an analogy here. The index key of this case would be the fish name. Okay. So after a few weeks, Bob was sad because he was just fishing 4 different kinds of fish. And he was expecting something better. But okay, passing for this, the problem begins here. If someone came to him to buy a cod or a salmon, it's okay because the cod and the salmon are in the first row, so it's easy to reach those buckets and get the fish from there. But if someone asks him to buy the green fish or the red one, he was having problems because to access those buckets in the middle were not so easy. Okay, so this was a performance problem, I can call, for his selling process. Okay, and more, all those buckets were taking too much space of the place that he has to put the buckets. And this was useless because most of the buckets were empty. So why have all the space occupied by buckets? So in the end of the day, we have here the analogy for the high number of buckets. So all these buckets are taking too much space, much more than needed, and also he is having performance problems because of the fish not being too much accessible. Okay, so Bob, after some weeks, was convinced that okay, I'm fishing only 4 different kinds of fish, so I'm going to reduce the number of buckets, and this way I will be able to sell more fishes more efficiently. And yeah, he just brought 4 buckets, okay, and was okay. He was selling very quick because and also the space needed was not that much as before. He was even able to not pay too much for the lot, for the place to put the buckets. He was very happy. But what happens here? After some time, he started to fish more other kinds of fish, and he was shocked. You can see his shocked face, very beautiful. He was shocked because he started to fish more fishes. I don't know why. He doesn't know why. Maybe because the season changed. But yeah, so he has a problem now. He has only 4 buckets and 7 different kinds of fish. What to do here? The only solution was mix different kinds of fish inside of the same bucket. Okay, it can work. But yeah, this is that scenario with the low number of buckets. You can have hash collisions. Why? For example, if someone goes to Bob and asks, I want a cod. He was going to the bucket labeled as cod and start to look for a cod, but he has also a green fish instead of this bucket. And yeah, so he has a chain of fishes inside, so he needs to look each one in order to find the right one. So if he needs one cod, he can go there and look, it's a green, okay, I don't want this, another green, I don't want this, a cod, okay, a cod, and he can sell. If he wants more than one, he needs to keep looking for cods inside of this bucket. So this is the scenario of the hash collision. Okay, you have different kinds of different index keys, I can call it this way, inside of the same bucket, right? So summarizing this, the possible problems with the bucket here. First one, low bucket count. You can have hash collisions, as I just showed. And the high number of buckets will use more memory and waste memory, basically, because you are reserving memory for nothing. And you can have performance issues because you need to pass over few buckets for nothing also. And okay, I will make a quick demo here to show the behavior of this. Let me minimize this. I hope you can see my screen. I'm going to make this bigger for you. Okay, so I have a database here, the famous Adventure Works database. And I created a memory table called demo table in man with the following structure. You have ID column, name column, and club column. So this table, what this table is recording? So name of people, persons, okay, and club names. Club, I'm talking about football clubs or soccer, and Portuguese clubs, by the way, okay. So let's make a quick select here. By the way, I inserted all those rows in advance here. a lot of rows, okay, with names and the club name. Okay, so I am going to increase this. Oops, what's that, man? Okay, I don't know why this is happening, but okay. Okay, so I hope this this is okay this way. I don't know why this is not working, but okay. Again, no. Okay, no problem. So you have here this first row set here is the total number of rows in the table. You have 101,920 rows in the table. This second set here is showing the number of rows per club. Okay, then so looking for here, we can see that you have 3 different clubs. Okay, and for each club you have that number of rows associated. Okay, so basically you have that number of people supporting those teams. So Benfica has 84,905 supporters, supporting 15,000, Porto 1,000. Sorry, Nico. Okay, so for the names here, this third one, you have the number of distinct names in the table. You have 1,994, almost 2,000 different names on these 100,000 rows. Okay, so let's keep looking to the, let me just do this. Let's keep looking to the table structure here, and you can see that I created 2 indexes when I was creating this table, this in-memory table. One index for the name, another index for the club. Both are hash indexes, you can see here, hash. And I had to define the bucket count value here. So for the name, I defined that I would have only 50 buckets to store the names. And in other hands, I had for the club defined 100,000 buckets. Okay, so just looking for this, you can see you have 3 distinct club names here, 3, and we have 100,000 buckets to store 3 distinct clubs. Okay, this is not good so far. Okay, and for the names, we have 50 buckets and we have almost 2,000 names. So what's the thing here? So we have a DMV, this DMV, okay, for memory optimized tables, and I did the select is there already, but I'm going to select. Oh, okay, this way is fine. The result is here, okay, and let's analyze the first index, the index of the club. So first thing, the total number of buckets. We have here 131072 buckets, okay, and I defined just 100,000. Okay, so it's different, it's a different number. And why this? Because SQL Server rounds this number to the next power of 2. Okay, you can see the same thing here for the name index. I defined 50 buckets and SQL Server rounded this to 64 because of the same reason. This is rounding to the next power of 2. Okay, so keep analyzing the index club. We have all those buckets, and we have a number very close to the total as empty buckets. Okay, if you notice, you have here the total number of buckets less those 3 distinct names. Okay, so is 131069 empty buckets against 131072 of total buckets. So yeah, we are just using 3 buckets here, and this makes sense here, right? And you have a very big chain for each bucket. Each bucket will have a chain of values, okay? And the average chain here is 33,000, almost 34,000 rows, okay? And some curiosity here, the max chain length is 84,905, which is exactly the number of Benfica supporters, okay? So is what we are using here. Another thing to look here is the space allocated for all those buckets. I said before that we use 8 bytes per bucket in order to have those buckets there. And in this case, we have all the space allocated and only using this small amount. Okay, so this is not being effective. You have too much buckets for not too much utilization. In other hands, for the names, you can see it's very different. You have 64 buckets and everything is used. You have 0 free buckets. The length is it's not that big like the clubs because they have more distinct names than clubs. Okay, anyway, we have a length here, but the curiosity here is we are using everything and all the space is used. So, in the end of the day, we need to find a value in the middle here. We need to avoid the first problem and the second problem. We cannot have a too high and a too low value. Okay? So let's go back to the presentation and talk about checkpoint files. Okay, so when you are using memory optimized tables, you need to create a file group, a special file group for memory optimized data. This file group is based on file stream and is basically a container of checkpoint files. Okay, checkpoint files are actually a pair of 2 files, a data and delta files, and those files are responsible to recreate the rows of durable tables on memory. On memory, you can have 2 kinds of tables, durable and non-durable. The durable tables, when you restart the SQL Server, you can rebuild all the table with the rows inside as was before. With the non-durable tables, once you restart the SQL Server, you lose everything that is there. Okay, so you have advantages in having this. Okay, you can choose between both. So one, you have more performance than the other one, but the durable one will keep your data safe. Okay, and the checkpoint files are responsible to keep those rows safe. Also, those rows are logged. All the operations that you do are logged for durable tables. But okay, going back to the checkpoint files, I said checkpoint file is a pair of 2 files, of course, a pair. One is the data file, another one is the delta. The data file is responsible to store all the inserted rows, okay? And this can be generated also by updates, because when you update, you are doing a delete and insert, okay? And the delta file is always a pair of a single data file, right? And this delta file is storing the IDs of all the deleted columns. Again, you can specifically delete the row, or when you are updating some row, you are deleting and inserting. So updates are creating data inside of a data file and the delta file. Inserts are creating data inside of a data file, and that's it. And deletes are creating data inside of the delta file. Okay? So, what's the problem here? When, you are inserting data, deleting data, updating data, so the life cycle of the table have a lot of changes there inside of the table, and the older checkpoint files will be in a not too good state, I can say. Why? Because as you are deleting rows caused by deletes or updates, you are increasing the size of the delta file and invalidating data that is inside of the data file. Okay, so what's the problem with this? The problem, first one, is the disk space, because the files are just increasing to track data that is not needed anymore. And the second problem is the recovery. When you need to recover the database, you need to read huge files, bigger than the normal. And so the recovery performance will not be the best. So we have a merge process in order to to avoid the problems, the problems that I just said. For example, here, you have the checkpoint files represented by this single page here, okay? But this is, imagine this as a data in Delta file. And this first checkpoint file is responsible for the timestamp from 200 to 299. The second one from 300 to 399, okay? So both data files here have a lot of invalid data, and both Delta files have a lot of deletion tracked there. So you are going to make a merge. What the merge does? The merge will get all the valid data and create a new data file with only valid data, ignoring and discarding all the rows that has been deleted before, and create a new file and deleting the old one. So from here you can see this one started in 200 and this one finished at 399. And this new file will cover all this timestamp with only valid data. So this way you can save disk space, and the performance in the recovery will be better. Okay? So what happens when you fill up your disk? You need to track the table is in memory, okay? But when you have durable tables, you need to make sure that your data is safe. So SQL Server will log in the transaction log, and also write in the checkpoint files. So I'm going to do a demo here showing what happens when the disk is filled, so when you don't have space to grow with these files. Okay. So let's go back here to the lab. So basically, my checkpoint files are stored here in this folder, checkpoint files, in the disk E. So we can check here, disk E has a lot of free space. We have 70 gigs of free space. But now I'm going to force two things, okay? First one, I'm going to check, I'm going to fill the disk, okay? So for this, I'm going to check the free space here with this command, and I'm going to copy because I'm lazy. So I'm going to copy this and change this bat file to put the proper value. This bat file will just create a dummy file to fill the disk, so we have no more free space. Let's run this. Cool, very quick. And check here the free space. So now we have 0 bytes of free space, okay? So going back to Management Studio, let me fix this. The database is here, is online, and now I'm going to execute inserts in the table in order to check the state, in order to check what's going to happen, okay? I was surprised when I tested this for the first time with the solution, the result of this. I don't know why this is open another Management Studio, but I closed this one. So let's start execution. Let's see what's going to happen. Okay, so the command is being executed. You can see here how the CPU is performing. Our memory is kind of stuck. It's like 3.9, nothing more. The command is still being executed here. And boom, okay. This failed. Okay, this is expected. Okay, you don't have space to grow. Let's check the home message. So first one is the log for database adventure works not available. Okay, log. Yeah, this makes no sense. Okay. Second one, during undoing of logged operations in the database, an error occurred in the log record, blah, 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 blah. Okay, yeah, so error message is nothing pointing to a full disk. Okay, so let's check in the database to see the state of the database and what you can find there. So I'm trying to refresh this. I hope this works. Okay, cool. Oops, okay. So the database is in recovery. Let's try to access, oops, we cannot expand the database. Let's try to check the properties. Oh, this is not responding. So basically, you have a database with, in this particular database, I have a mix of in-memory tables and the traditional disk tables, okay? And even with the problem being only in the memory tables, I have all the database offline, and this is very bad. I was not expecting this actually. I was expecting to have, of course, the inserts failing or updates failing, but having at least the table as read-only. But no, the database, the entire database is offline now, okay, in recovery stage. So the only way to recover this is go here and delete the file. Let's delete the file. So basically, we are getting more disk space. And let's go restart. No, okay, we can restart the instance or just go here and take the database offline and make it online again. So let's take offline. In this case, I could restart because it's only one database here. But yeah, in a production with more than one database, this makes no sense. Let's bring it online again and check if this will recover properly. We can check also this task manager, memory utilization, CPU very loaded. Of course, this is a VM, okay. The performance is not the best. Okay. So basically, the database will become online. We recover. Okay, it's in recovery stage now, and hopefully this will be recovered. Okay. So let's leave this recovery here. Oops. And you can see the data was loaded to memory here. You can see the increase of memory utilization. And okay, so let's leave this recovery now and go back to the presentation. So I have the last demo here in the server, and we can get the database recovered. Cool. So just to recap, possible problems with insufficient disk space when you have checkpoint files there. So you need to monitor disk space, okay, and avoid a lot to have the disk filled, okay. If the disk is filled, you can cry a lot. You can see it's not good to have the production database offline. So be careful with this. The thing here is not alert when you have like 10% of the disk of free space, because this can be used very quickly depending of the load that the table can have. So be careful with this. So going to the last point here, available memory. As said before, everyone is monitoring memory on traditional instances. But yeah, here we are dealing directly with the memory. We are using in-memory tables, so we need to monitor memory as well. Okay, so let's check the scenario here. We have here is like a map of the memory. I distinguished the SQL Server memory and the memory located memory just to make this clear. Same thing with the OS process. And I have here that amount of free memory. Okay, so we start to use the server, and in memory takes more space in memory. Same thing with the OS processes. And going ahead, you can see memory is taking more, OS processes a little more as well. And yeah, I don't know, but suddenly you can have like a crazy antivirus there, or some program that someone installed and that you don't know because you are the DBA, not the sysadmin. And this program took the rest of the free memory that you have in the server. So before of this, okay, at maybe this stage, you are okay. From when you have this little amount of free memory, you need to be alerted of this, okay? So we have two solutions here to to avoid the memory optimized table to take too much space. First one is user resource governor, and actually this is the solution for the memory table. And the other solution, because if you go back here, SQL Server is taking some space, and some space here is used by, most of this space is used by the buffer pool, okay? And the in-memory table space, the in-memory tables are taking space in memory, and this allocation has priority over the buffer pool, okay? So if in-memory needs more space, space from the buffer pool will start to be still, okay? So the pages from the buffer pool will start to be paged out, okay, out from memory, and this will compromise the performance of the traditional tables as well. So the buffer pool extension is a good option, a good solution to minimize this impact. Buffer pool extension, for who doesn't know, is basically you put a SSD, a fast disk in the server, and you create a file to be like a second level of cache, okay? Not that quick as the memory, but better than have to access the disk, right? So you can use these solutions to minimize the problem. Don't use all the memory of the server. Of course, you cannot control what the OS process is doing, but you can monitor this. Okay, so the possible causes here: OS process taking more memory than expected. As said, you can have a crazy antivirus doing some sync or some other program that is taking a lot of memory, and this will make SQL Server need more memory and cannot get this. So the second point is not enough physical memory. When you were in the project phase, you said, okay, I'm okay with like 200 gigs of memory, and in the end of the day, this was not enough for your needs, and this is a problem. Okay. So the third one is in Memory OLTP taking more memory than it was supposed to get, and this can be minimized by the use of the resource governor, but of course the resource governor will cap the memorialization of the memory tables, and this will return errors to the end user. Okay, so the best is really monitor and anticipate the problems. So let's go to the last demo, and I hope the database is recovered. Okay, that's great, it's online. Okay, so I'm going to do the following here. We have this tool, and I will make a lot of load in the server and use all the available memory and show the behavior of the server. Most of you know this, but yeah. So let's start this. This takes some time to start. And while this is starting, I'm going to execute a script here to insert data in the memory optimized table. Let me just find this. Okay. Let me find the script. Okay. Yeah, basically, first I'm going to show the following. This, I'm not using resource governor here to show this. And you can see on this script that I'm going to show now that I have the resource governor enabled, but I didn't bind that database to this resource group. Okay, so I have this pool, okay, for Adventure Works, but the Adventure Works is not assigned to this. Okay, so what's going to happen? If I start inserting things here, the data will be inserted and the memory will be utilized until you have free memory, right? And in the same time, we are loading the memory of the server using this heavy load tool. You can see the server is already slow because I'm running this. It's very heavy actually. So let's insert more data here and see the behavior of the server. let me just open the task manager and show. Okay, you can see the memory utilization grows a lot. And the thing here is the Windows behavior is nice. Okay, when Windows feels that the memory is being extinguished, it tries to page out the much it can from the memory in order to free space in memory. You can see you have some oscillations here. The memory's utilization is increasing and decreasing and increasing, decreasing, because Windows is trying to fight against all this memory utilization and make the system up and running. But at certain point, we will use all the memory or most of the memory. You have only 93 megs of available memory, and this is increasing. Okay, Windows is fighting. And okay, this is executing. We are connected to the server. It's okay, but the memory utilization is increasing, decreasing, increasing, decreasing. And at certain point, what's going to happen? We will lose connectivity to the server. You will not be able to access the server. And I think this happened now, by the way. Let me check. Yeah. Oh, no. This is still, I can see it's still refreshing here. But the server is misbehaving at this moment. So at certain point, even the RDP session will not be working. Okay, so the only solution here would be restart the server. So the memory utilization is very important to be checked here, not only for the memory OLTP, but also for the traditional tables as we have now. And with this instance governor, we can limit at least the utilization from the memory optimized tables. This way, we avoid extra problems. Okay, at least the server is online. But we need to take care with this because this can grow very quickly, and when you see you don't have server, the server is unavailable. Okay, so let's go to the next step here. Okay. The server, we can check this like in a few minutes. Probably this will not be accessible anymore, but let's go to the final part here. It's almost time. Okay, just to show how to monitor, I have here some solutions. Okay, and as I said before, I will make this available for download. I will send this to the virtual chapter. I used this script here for the bucket count problem to avoid the hash collisions. Okay, I built this T-SQL script based on these DMVs. Okay, and basically I set here a minimum percentage of free buckets and a maximum percentage of total tables rows per bucket. Okay, this way, when we pass this threshold that I defined here, I put here 10% and 1%. This will raise an error. So we can put this in a job, and the job will alert the DBA, or at least will fail, and you know that something wrong happened here, and you can take a look. The problem with the bucket count is when you need to fix this, you need to recreate the table. Okay, so again, the better is try to solve the problem or avoid the problem when you are creating the table. Okay, so for the high bucket count, the same thing. I'm still using the same views, but I have only one threshold here, is the maximum percentage of free buckets. The same thing. So when you pass the threshold, we will raise an error. Okay, this using T-SQL. For checkpoint files, that problem with the disk space is disk space. Most of the monitoring tools nowadays are checking for disk space, but I built also a PowerShell script that you can execute this inside of a job. It's not the best, but you can put this inside of a job or a task inside of Windows. And this is monitoring the disk space. I have also a threshold here, 25%. And when the disk space is less than 25%, I will be alerted as well. So OS processes take more memory than expected. So this is kind of tricky. I have this PowerShell script, and this PowerShell script is just looking for the utilized memory for the processes that are not SQL, you can see here. Okay, this was the way I found to filter the non-SQL processes. So you can sum up all the memory utilized by the other processes, and then you can like set a limit. I set that 10% of the memory space is okay to be used by other processes for a specific case. Of course, you can change this threshold. And if other processes started to use more than 10%, I will be alerted to avoid a problem. Okay. And the last one, the high server memory utilization. Again, most of the monitoring tools that you have are looking for this. And yeah, this is like a variation, a derivation of this first, this previous script, but I'm just looking for the total utilized memory against the available memory, and set again a threshold to alert the DBA or the person that is monitoring the server. Okay, so that's it. Thank you. I think, let me check here. Yeah, just in time, 6:55. So Nico, I think this is with you now. Nico, are you there?
All right. Yes, I am. So there is one question from Ashish Kale, who is asking if is there a limitation to the size of the table to load in memory?
Yes, as I showed before in the limitations, we have a limitation of 250 gigs of to be utilized for this memory table. So yeah, it's still not too much, but we have a limitation there.
So this means that one table can reach 250 gigabytes.
Yeah.
That's the maximum.
Yes, yes.
Okay. More questions. Since nobody posted, if you have any questions or comments, now is the perfect time to comment or to ask questions.
Yeah. Also, if you want to send me something in private, can put my contacts here again. I can contact him by Twitter or LinkedIn. So I can answer the question if it's the case.
Yeah. And a further question from Ashish is, or maybe a comment. So, not a good idea to use a fact table in memory for a data warehouse.
Yeah, if you have a very big fact table, yeah, it's not a good idea. Yeah, but Nico can talk about clustered indexes, column index actually, and this would be a good solution. I recommend you to check Google for Nico ports, and you have few articles there about this, and this will be a good solution for you.
Okay. Okay, so you just confirmed, Ashish, so not a good idea to use a fact table for in-memory OLTP. Okay, Joshua Flory made this comment. Just wanted to say thanks for the demo. It was interesting to see. I also was not aware of some of the dangers or gotchas to look for, such as running out of space. Thank you for showing that. Okay, thank you. Okay, another question. Can you mention the tool he mentioned to check on Google? Can you explain the tool you were showing?
The tool to load the server, I mean, right? Yeah, it's heavy load is the name of the tool. Okay.
Can you insert some link into your slides so when we publish them, people can check out this tool?
Okay. So yeah, I'm going to do this, and yeah, I will attach the scripts as well, so you can have all of this that I showed here.
Okay. So, but the tool's name in the meantime is heavy load.
Yeah.
Correct?
Correct.
Okay.
Correct.
Ashish says thank you, appreciate it, thanks. Charlene Ney says thank you for the information. More questions or more comments, please? We've still got a couple of minutes.
Yeah, people are shy today.
No, I don't think that they're shy. All right. Okay.
Okay, I'm still new. Okay. Okay.
Okay, no question at this time. Okay, thank you, Delphine.
Okay.
Thank you, Murilo, for giving a great presentation.
Thank you.
Thank you, everybody, for attending the session. Please stay tuned. We are working on more in-memory stuff. We will be publishing the next presentation for the next month, hopefully in the next couple of weeks, maybe hopefully this or next week. And you will find a lot of great resources at our page. Go to our homepage, emvc.sqlpass.org, and there at the resources we publish some of the links to some of the in-memory articles or books that you might find useful. Thank you very much for attending, and hope to meet you virtually again next month. Take care.
Thank you. Bye-bye.